when it's just solving straightforward ones, where you've got cos or sine a number or tan a number, we now need to consider alternate types. So, let's try and remember, what would the sine of y equals 2 sine x look like compared to the sine x curve? So, here's normal sine x, so 90, 180, 270, 360, 1 and negative 1. It goes up, down, down, up, yeah.
Oh, would it just like stick if you like stretched?
Would it go up higher?
Would it be stretched out? Stretched
Would it
in?
go up to 2 and down?
Alright, okay, hang on a second. So, Olivia said, would it go up to 2 and down to minus 2? What do we think?
No.
Why?
It's because it's a wire.
But
it's not the y value, it's
No. Where would the 2 be if that was the case?
Oh, it would be on the
Where?
on the end.
in the
I
y.
don't know. Next to the
That
Y. Next to the Y.
It would be in front of this. Okay, so if the 2 was here, in front of the sine x, then that, you said next to the y.
No. I'm not for that.
So if the 2 was here, then it's going to stretch it that way. Okay, so you knew that the 2 was going to, that stretch happened some way, but that's when it's there. When it's inside the function, what's going to be affected?
Go up. I mean the x-axis of it.
The x-axis is going to be affected. Yes. How is it affected?
It's stretched. It's squished. It's one of the.
Which one is it?
It's stretched. It's squished.
So, when you've got y equals 2x, what this tells us, this 2 tells us how many cycles we're going to have in our normal period.
Oh.
Do you remember that little tip?
Yeah.
So when this number is different, that tells you how many cycles you're going to have in your normal 360. Which means that what's happened is that rather than having 90, 180, 270, 360, we are going to still have that, but what we need to consider is those midpoints, okay? So it's still going to go up to 1 and down to minus 1, but it's going to do it much faster. And that means that we've actually done 2 cycles within the 360. You had your hand up.
Yeah. So then what would it look like if it was stretched? Would the 2 be on the other side?
No, there would be like a half
I see.
or a third, something. Yeah, because you've only got a portion of your graph only in the 360.
So would there normally only be one cycle in the...
Yes, because not for a sine x, it's a secret one. So you would have 1 cycle in your 360. If this is the 2, you'd have 2 cycles in your 360. Yes? Okay? Happy with that? So what's going to happen is that where, for example, we've been solving these and drawing lines and saying, oh, lovely, I've got 2 solutions here within my 360 degrees. How many solutions would we have here?
4.
We'd have 4. Yes? So when this number here is changed, it means that you're going to have more solutions to consider. Okay? That's why I want you to think about overall, but we're actually going to start each question in a very similar way than we did the others. Okay? So what rounding are we written here? If we usually obtain 2 solutions for 360, how many would we expect for 1, 2 sine 2x? So we would have 4 solutions. Alright, so we've been asked to solve sine 3x equals 0.7. Okay, right, so in our heads, we know how many solutions are we probably looking for?
4.
Careful.
3.
What? I didn't even look.
Okay, the question is solve sine 3x equals 0.7. How many solutions are we probably looking for? 6. You all happy with that?
Yeah.
Because normally it's 2, but we're looking for 6. So in our heads, we're thinking 6 solutions. Okay, I'm going to put that in brackets because we're going to come back to that later. They only want between 0 and 360. Okay, so what we're going to do is we're going to say, hang on a moment, I got quite good at solving just sine of x equals something, so that's what I'm going to do to start with. I'm going to pretend that this here is just a. Now, a is random, there's no reason I've chosen a, okay? I'll just use a different letter than I had here, okay? So, sine of something is equal to 0.7. How do we do that? How have we been doing that? Well, we've been drawing a line at 0.7, yes? We draw our things here. Then what do we do? How do we find this one? Oh, yeah, okay. So when you say rearrange, what does that mean?
So we do the
Negative 1. Minus
Yeah.
1.
So A would be sine to the minus 1 of 0.7. And we all wanted to stay in degrees, didn't we? If it was in a radian, we were going to change. So it's all degrees. So okay, so let's find that value.
44.
44, is that 3 sig fig? Is it exact?
0.4.
0.4. Alright, so there's our first solution. So that's this one here, the 44.4. How do we find this, baby?
180.
Good girl, because of the symmetry, yes. So we know that that value represents 44.4. So then this 4 would represent it. So that's 180 subtract 44.4.
135.
135.6. Okay, and normally our question would be done. We'd think we were awesome. Question finished. Okay? But what we've actually done is solved 3x is equal to 0.6. No, what we've actually found is 3x is equal to 44.4 and 3x is equal to 135.6. Do you all see that?
Mm-hmm.
Yeah? And that's not what we want. We want to find out what x is. So it's at this point here, I've said now think about how many cycles will take place. We know it's 3 cycles. So that's why we're going to need to find 6 solutions. And at the moment, I've just got 2. So what we're going to do is, how do I find more solutions? What was the thing that we said the other day? If we wanted to find more solutions to the right or left, what do we do with these 2 numbers? Careful, you add 360. Why are we going to add 360 to these numbers? Because that's the length of the cycle for the sine curve, yes? So, we've got one solution is 44.4, we've got 135.6, we need to find the others. So what's 44.4 add 180? Oh, shut up, 360.
464.4. No, that's
You're adding 44.4.
It's 404.4.
I was right. That's what I said.
No.
Never mind.
Never mind. I'm done with this.
If it in my head, I was right.
I'm sorry.
What else?
495.
How did you get that one?
I added 135 to 360.
Right, so that's 4 solutions now. We've got to keep going, because remember we need 6 solutions, yeah?
So add 180.
Negative
Not 180.
360.
Yeah.
Negative 315.6.
Now, you've suddenly started taking it away. Why have you started taking it away? So that would only be if, remember up here,
They wanted between 0 and
remember up here, they want between 0 and 360. So none of your answers is going to be negative. Okay, so you only take it off depending on what the range is up here. Now, Olivia just said, well, hang on, that's not in our range. It's not yet. Okay, so I did say, I have said here, don't worry, they're not in your range at present. Okay, they will be in a second.
664.4.
664.4. Oh, that's so not a form attachment.
I got 7.
It might be that as well.
Right, what's 404.4 plus 360?
764.4.
Is it actually?
Okay. Okay, we're good so far. Yes? So we've now got 1, 2, 3, 4, 5, 6 solutions. But as I said, they are all solutions to 3x equals, not x equals. So what do we do with those numbers now?
Divide by 2.
Divide by 3, yes? So each one of those numbers, we're now going to divide it by 3.
You just said it was plus.
Okay, so up here, Jen, we were initially solving sine 3x equals. We changed it to be sine a equals. So this here, these two solutions are a. Yes? But a represents 3x. Okay, so we found 6 solutions, but they all represent 3x, not x. So what we're going to do now is divide all of them by 3. 14.8.
45.2. 134.2. Can we do
So we do this.
495.
Okay, then 254.8, and then
285.
Point 2. Now, at this point, you look at all those numbers and say, are they within our range?
Yes.
Okay, so because they're all within our range, we're good to go. Does that make sense to everyone, what we did and why we did it?
Why did we change it to A in the first place?
Just because we could have kept it 3x equals, but I don't know, I just like to say A equals. You don't have to do that bit. You don't have to. You can keep it as 3x equals if you wish.
Okay, it was so basic. It doesn't matter.
No.
Okay.
And I chose A randomly, no reason for A either. Okay? So, as I said, I'm more concerned that you understand what we did and why we did it for this question, because we're now going to do similar things for other questions. So what we did is we looked at it, we saw that it said 3x, so we know we've got more solutions. We pretended that it was just x, so we sketched our normal sine curve, found our 2 solutions. But because we need 6 solutions, we need to find loads more. Now, again, this is my way of doing it. I like to find these big numbers because you're always just going to be adding 360 to it, rather than finding these two and then adding your new period to it. I just think it's way easier. Hopefully you are thinking that's quite a nice way as well. So we found our 2 normal solutions, we found the other 4 that we knew we were going to need, and then we said, okay, hang on, that represented 3x, so we now divide them all by 3. Now, a question for you. If we've been solving cos 2x, how many solutions would we have needed to find? 4. So we would have found our 2 initially, and then we would have added 360 just to both of those 2 once. Yes, so we would have ended up with 4 numbers. And then we would have divided those 4 numbers by 2 instead of the 3. Yes? So
Is
that's,
it double the number in the sign you get that into the 2?
yes. Now, I want to say it's always that case. There are a few moments where it's not. So for example, if you're doing between 0 and 360, you're solving sine x equals 1. There's actually only one solution here. Okay? So there are few and far between situations where the doubling the number, or it's always 2. You can't always say it's 2. Most of the time it's 2. For example, if you were solving when it was 0, you've actually got 3 situations where it's 0. So you just have to know your graphs, is what I want to do, and that's why I get you to sketch it and draw the horizontal line, so you can actually see how many solutions you're looking for. And remember, where this line is not important, as long as it's roughly in a good position. Okay? Alright, used to solving stuff like this, what are we used to solving? Just sine x and cos x. Yes? So what do you think we can do with this? Okay, how you can do that? At the moment we've got 4 cos x. We're going to divide by 4, yes? You happy with that? So our first step here is to change this from saying 4 cos x equals 3 to cos x equals 3 over 4, yes? Well, actually, this is now a cinch one, very similar to what we did the other day, yes? It just happened that the first step was to rearrange it. So, cos x equals 3/4. Well, what's the decimal value of 3/4? So, we're going to draw a line along here, yeah? We're going to find our 2 solutions, so, and, oh, that didn't hit it. There's our 2 solutions. How do we find our first one?
We put it in the calculator.
Okay, nice. So we find x by doing what?
X is cos -1 and
Towards the end?
0.7.
You must be a radian.
Oh wait, I didn't do cos.
41.4. 41.4 is the answer. So this value here is 41.4. How do I find my other solution? Awesome. Said with major conviction there, Jen.
Yeah. I was like really trying to.
So 360 take away 41.4 is?
I can do this in my head.
380.
Right, okay. Cameron just asked a question, will this be on the non-calc? These ones would not be on the non-calc. Okay, so these would all be on paper 2. However, they do have these questions on the non-calc paper. But remember, what did I say about things that are on the non-calc paper? What kind of what kind of answers would you have? You wouldn't have 41.4. It would be the special kind ones, yes? So you do have to remember those. So it could be in radians as well. Yeah? So perhaps we'll remind ourselves about those in a second. Okay, we all good with these though? So there's our 2 solutions. And check the actual original thing. It's just cos x, so there are only 2 solutions. Have we got those 2 solutions in our correct range? Yes, question finished. Okay? So that one was quite a straightforward one. Huh? Alright, so C. Well, this is a bit way more complicated. A bit way more. So, what are we going to do with this bad boy? Not yet, Sarah. Why not yet? Well, Sarah wants to rearrange it, but she wanted to divide by 6 straight away. You've got to add the 2 to both sides. I'm so sorry, sweetheart. I didn't hear that. So we're going to add 2 to both sides to get rid of that. So we've got 6 sine 2x equals 3. And then sine 2x equals 3 over 6. So sine 2x equals 1/2. Oh, they didn't give us a range. That's a bit silly. What range should we have? 0 to 360? Oh, God, we're boring, aren't we? Alright, so we're solving sine 2x equals 1/2. What's different about this one? How many solutions are we going to have? 4. So we know we've got 4 solutions. But for now, we're just going to find our usual 2. Less 2. Less 2. So we're drawing our line at 1/2. How do you find the first one?
Put the calculator.
Put the calculator. It's going to get boring when I keep asking you this. So sine A equals 0.5 5. But I want to keep asking because I want to keep on it and getting the right answer. So what's one of the solutions? Secretly, this is a special. And then how do we find this other one? So this is 30. Really?
Wait, no, I like 150. Oh.
I love your enthusiasm to do it in your head now. But don't rush it, because it's so horribly wrong.
It's embarrassing, confusing.
And we're recording it.
Oh my god.
Alright, so there's our 2 solutions, but we remembered that we need 4 solutions, so what do we do with both these 2 numbers? At 360, so I've got 30, 150. And at 360 this gives me 390, and 360 to this gives me
510. Wait, I lied.
510. Oh yeah,
Wait, no, I'm right.
yeah.
Oh, I wasn't calculating.
Those bad boys aren't in our range,
So you divide
but that's because we've been solving sine 2x equals. What do we do with them? Divide by 2. So our final answers are 15, 75, 4, 1, 95, and 2. And all of those solutions are in our range. Okay.